I really suck at creating visually pleasing things. I mean, look at my thumbnail for example. But what I am relatively good at is coding. Now what if there was some kind of a way to compensate for my incompetence in visualizing things with coding? Meet Manim, Community Edition. It's a Python library which lets you do really cool visual stuff. Usually people create highly complex math and physics simulations, but I am neither a mathematician nor a physicist. What I am though is really excited to learn. The plan is really simple. First, we learn Manim using the documentation it's provided, and second, we visualize the n-body problem to stay on brand with the physics and math stuff. And if you don't know, I'll explain the n-body problem later in the video. For now, let's learn Manim. Yes, of course, yes, say yes to everything. What could go wrong? What could go wrong? Nothing could go wrong, ever. Something went wrong, okay. Let's just install that. Oh my god, why is like this happening? Like, whatever. Now, I don't know what I... Wait. We did it. We created a circle. That's basically the hello world of Manim, if I'm not mistaken. So progress is booming. It's booming, okay? We're basically there. Where is that saved, by the way? Is that saved anywhere? It's saved in media. Oh, we can have images. Create circle.mp4 partial movie files. Now, I have no idea what that's supposed to be. Okay, for a second animation. Alright. Oh, we're almost there. We're getting close. We're getting close. The hamsters are running really hard. Okay, creating, doing that, rotating. That's what I wanted to see. Perfect. Perfect. Okay, that's my first Manim not application, animation. That's my first Manim animation. That's pretty cool. That's pretty cool. Let's try to do something more complex. What we should see is that we display a square, we display a circle. The circle, and at the same time the circle turns into the square and the square turns into the circle in parallel. So let's see. Right. Perfectly executed. Perfectly executed. I have no complaints here. Okay, at least I'm learning from my mistakes quite quickly. See, I love programming. Every time I play with a new tool, I just remember how much I like programming. Modularity really helps the readability, really, especially if it's like one big file, like it is usually with Manim, you know, the library. You really have to go with modularity. I was wondering why it's such a low quality. I was using this PQL, which QL quality low and P was automatically played, which was the three things I didn't want. That explains why it was such a low quality. But now that I ran this command, which removes all three of these flags, yeah, that looks a lot better. It looks like a 3 blue 1 brown animation. Or is it the opposite? 3 brown 1 blue? You know what I mean. Oh, I wonder if I do like QH, will it render even higher quality than 1080p? No, okay. I thought it would be something like 4K 60 FPS. No, okay. We're chill. Is that, yeah, it's 3 blue 1 brown. This guy, really cool, extremely smart. He made this whole library, and if you've seen any of his videos, it's all just so amazing. He's such a smart person, and he explains all these such complex topics so easily, and he does that with the help of this library. Now, something actually fun that you might not know is that it's all rendered in 3D space. So what you see is actually 3D space, just flat. so it looks like 2D, but all this circle we created, this square we created, it's in 3D space. So oh, it's so cool. It's so dope. So amazing. Okay. Let's stop nerding out and continue. Now, sections. In addition to the movie output, each section produces its own output video. Oh, that's even more modularity. I love modularity. Just if everything could be broken down into small little conceivable pieces, it's so amazing. Even more modularity. It's so cool. Created. Oh, so I saw that. So that section break. Oh, it knows. Copilot is... Copilot knows me very well. Yeah, okay, so... Amazing. I don't know if you saw that, but Copilot just out of nowhere, like it hallucinated this function that it just doesn't exist. Amazing. That's why usually I don't use Copilot. To be honest, I don't know how to turn it off right now and I don't want to be bothered, so we'll just roll with it. In theory, I should get one video file and two that are creating the square and creating the circle. And that's why I love modularity. No problem. Creating the square, creating the circle. Amazing. Huh. I hadn't thought about that. I absolutely hadn't thought about that. Every time you generate a new section for a video, it creates a JSON file, and this JSON file can be used by third-party applications to use the video, knowing the width, the height. A good way to describe an object is something that can be rendered on the screen. Everything that can be rendered on the screen, I guess. So circles, arrows, rectangles, axes, function graphs, bar charts, waves, everything that can be rendered on the screen is a kind of object, Manim object. If we're trying to create something without animations using the .add command, it would just generate an image. That makes so much sense. Yeah. Okay. I'm nerding out a lot about this library, but there are obvious reasons why I would nerd out about this library, right? It's not just me, right? The circle is animated into existence, it slowly feels pink, then its borders turn blue and at the same time get bigger. Let's look. Yes, I think. So it's like this and then it turns, yeah. Okay, that's cool as well. That's so cool. Everything is cool. I'm calling everything cool, but that's because I'm like nerding out that I can finally make animations, and it's with the thing I use the most, code. So code is my tool. I love it. Now, an interesting thing, I don't know if you saw the curve of acceleration. So it started really slow, then it went really fast, and then slowed at the end. That's the curve of speed, like the curve of acceleration for this animation. I know you can change the curve of acceleration. So, for example, the curve would look right now, the curve of acceleration of speed would look something like that. And so it's not linear, it's exponential at some point, and we can make it linear so that it moves with constant speed, but I'm just not exactly sure how to do that right now. We'll get to it. What does this super do? What? It's called super here. In C# we call that base for whoever is mad enough to use C#, but yeah, the super is good. Yeah. Okay, that's actually cool. We completed all the tutorials of the Manim documentation. We're an hour and 30 minutes into the stream, but we also managed to do a lot of, like, most of here, like all these 100 lines of code are animations that we did on our own, that had nothing to actually do with the documentation. We just got inspired by the documentation and created something of our own, which is the best way to learn. Use either text or markup. Wait, let's just create a new class, call it class text shenanigans. I'm telling you, this is peak way to name all your projects, all your files. Just add shenanigans to the end of each one. Just trust me. Why do you keep doing this to me? Why do you keep doing this to me? Just like, leave me alone. And what? Why? Oh no, wait, I'm stupid. Great, it's rendering. Great. Okay, let's look at text shenanigans. Hello world. Oh, beautiful. I love it. I actually love it. Okay, we're only an hour and 47 minutes, so that's no problem. We're perfect like that. So it just took us an hour and 40 minutes to type hello world. Before we continue, let me just explain what the n-body problem is. The n-body problem is about predicting how multiple objects, like planets or stars, move under each other's gravity. It's easy to solve for 2 objects, but with 3 or more, things get really complicated. Usually we need computers to figure out their movements when there are many objects, and that's why we're doing this animation. Oh, I'm really curious. Let's just ask Claude and explain what we're doing. I am simulating that. I'm really curious if it's actually going to work, so I'll just try it out, I guess. I don't know. I doubt it's going to work. Yet I'm really curious if it will just do it. I'm pretty sure. Oh, it did it. Let's see. It coded gravitational attraction. I'm curious if it will work. It's yeah, I wouldn't call that exactly working. Let's see, gravitational attraction. Amazing, exactly what we wanted. Perfect. See, when Cloud or ChatGPT or any artificial intelligence gives you code, just read through it. Don't copy and paste it. You know, you can change things that you like, you can change things that you don't like. See, I didn't like that function, so I'm not going to copy it. I'm just going to extract what's in the function. Simple. Let me just open my stream so I can boost my views again. Matter of fact, is it weird Python functionality, or is me just stupid? It's me that's stupid. Okay, good to know. Good to know. Good to know. Again, I blame Python. Python is not in the wrong. I am in the wrong. Oh, it's as simple as I'm stupid. So simple. Oh, Python. Why do you do this? Sometimes it makes sense, sometimes absolutely not. Oh, we're rendering. We are rendering. Yes. See, that's why ChatGPT and code cannot just write your code. It just doesn't work. It sometimes does. I am very curious. Are they move? They don't seem to be moving. Okay, something's rendering again. I'm curious what's going on. It's even going to take longer, so maybe I have some high expectations. Gravitational attraction. I really want to be hallucinating them moving. I just want to move. Move. What if I just increase, you know, hypothetically to 50,000 the gravitational constant, you know, or to 500,000, you know, just curious what will happen if they will decide to, I don't know, maybe move. I don't know, crazy. I know, crazy. No, they don't seem to be moving. No. Okay, listen, my balls are perfectly fine where they are. Alright? Jesus. People these days, I swear. Okay, I'm just going to copy everything to see if it works. I really doubt it will work, you know, just kinda... I don't have a lot of confidence in ChatGPT and in cloud, you know, neither, either, and neither. Let's see, come on, it's not going to work, of course, but might as well humor. It's not going to work. It's not going to work. God damn it, it works. What? I didn't expect it to work. Hold on. What just happened? Why isn't it working? Oh, it created a V group. Alright. This is great. I don't want it because it's messing up my phone, man. It's just giving me off energy, you know? The only thing that really changed was my circles, or what I like to call them, my balls. I'm sorry, I have to stop this shit. Hi, future me here. I made such a disgusting amount of my balls jokes that I'm removing most of them, so the fraction that you hear is not even close to how many my balls jokes there were. Like, I don't know. I don't know. Okay, let's see how these do now. Oh, okay. Yeah, sure. That's about right. Yeah, that's perfectly fine. Don't worry. It's exactly what I wanted to do, actually. Yeah. Okay, obviously it didn't do a very good job. It needs to be a full number. They should be able to retract off each other or bounce off each other with the same force they bounced with each other. Yeah, that makes sense to me. Boom. Oh, perfect. Ladies and gentlemen, I show gravity. I present to you gravity. You know what I mean? This was kind of amazing. I think I want to look at a longer version of this. Let's make it maybe 20 seconds, and let's add more balls to the equation, and let's make them bigger. Actually, now here's actually an interesting situation that might happen. We can't have two balls in the same position. It's like, I don't know how to explain it. If you have, now the way this program works right now is that if you have one vector that's pointing there and one vector that's pointing there, right? If because the velocity of the ball is compiled of vectors, so one vector is going there, one vector going there, and it hits a ball here. So this ball is going in a parabola and hits this ball. Instead of going this direction, it will go back to the parabola, which is not how the real world works, but you know, at the same time, we don't have random balls in space bouncing off each other and some imaginary borders. So I think that's pretty good. I think I'm pretty happy with how all of this came together. Maybe we can move the bow class to like its own bow.py. Yep. Because it will look prettier. Yep, it works. So the whole animation itself was about 85 lines, with the bow class being another 40 lines of code, which is not bad. Let's see what you've got for me. Oh, you remember what I told you about the parabolas? They just go back and forth and back and forth. Oh, I love this. There are so many different things you can do with gravitational attraction. There is a way to make one circle static and then put the bow into a second space speed, which basically means it'll just orbit around it. It's so good. There are so many different things you can do with that. If you want to play with it, I'll just leave all this in the GitHub and you can have as much fun as you want. So yeah, this should be everything that you need. Okay, I had a bit of trouble with GitHub, Git, because I'm not very good at it. But yeah, I think that's all, and yeah, you have a great day.